Right, so we've got a quadratic, q squared minus 3qx plus 5 minus q equals 0. It's got two roots, find the range of possible values of q. Okay, so key reason there for me is there, two roots. Two roots, so what's that tell us straight away? It tells us about the discriminant. It tells us that b squared minus 4ac is greater than 0. So what I'm going to do now is have a little think about what my values are going to be for A, B and C going into that. So let's have a little look because it's a bit weird. So we've got A is, there it is, so that's going to be just Q. B is there, so that's going to be minus 3Q. And C is the number on the end, so that's going to be that bit there, so it's 5 minus Q. So we've got like expressions in terms of Q for each of those things. So we've got b squared minus 4ac greater than 0. So here we go. We have got b squared minus 3q squared minus 4 times by a times by c, and we're told we know that's got to be greater than 0. So what we've got now is it's turned into a quadratic in terms of q. So minus 3q times minus 3q, that's going to become positive 9q squared. Now we've got minus 4q times 5, so that's minus 20q. Minus 4q times by minus q, so that's going to be a plus. And so that's going to be 4q squared greater than 0. A little bit of tidying up. Let's get our q squared terms sorted out. So we've got 13q squared, apologies, minus 20q greater than 0. And so yeah, what we've done is we've created a quadratic inequality. Now let's do some solving, and again let's proceed by this. Will factorise. There's not going to be a 2 bracket job because we haven't got a constant term on the end, so it's going to be a 1 bracket job. So let's go for q 13q minus 20. For now I'm just going to go equal to 0 because I want my critical values. Here we go. So my critical values are q equals 0, 13q minus 20 equals 0, giving us 13q is 20, so that q equals 20 over 13. Right, so I've got two values for q, my two critical values, so let's just have a think about how it's going to work with the inequality. So if I plotted the thing in terms of q with my two values, so there's q equals 0, and there's the 20 over 13. Now I'm thinking, do I want the bit that's above the axis or below the axis? So here we go. Let's have a look at that thing there. And so we want my quadratic, it's got to be greater than 0. So the bits that are greater than 0, where's my curve above the axis? Oh, that bit there and that bit there. So for that bit, what values of q are we? Well, we've got q has got to be less than 0 for that. And for this bit here, all of those values of q there, q is going to be greater than 20 over 13. So I've got two distinct regions, but now if we just go back up and have a look at my question, we can see, oh, hello, we're told that q has got to be greater than 0. So that kind of takes out that one straight away. So therefore our range of possible values, our solution here is going to be q has got to be strictly greater than 20 over 13. And we're done. Just a quick note on the end, it is always well worth being blatantly obvious in the exam that you've considered all the roots. For example, in this one we had two roots, we had 0 and 20 over 13, but because we knew that q had to be greater than 0, that allowed us to disregard that one. So we make it absolutely clear in our solution that we've considered it, got rid of it, and so we're left with just our one solution.